Hello, greetings to you. Welcome specially to the Engineer Construction Lecture Hub. Well, today we are going to look at a very important topic. As you know, we are taking the topics based on our outline. Okay, so today's topic we are going to look at is design, design, design procedure. Design procedure of ROC slab. ROC slab. That's the topic for today. Now, when we talk about ROC slab, we are basically referring to reinforced concrete slab. Okay, a slab that is made up of reinforcement and concrete. Okay, that is what we refer to as ROC slab. Now, understand that when slab is usually regarded as a structural element, okay, and there is always a way we normally adopt, to design our slab. And like I said, this design procedure is centered on Hero Code. So the design procedure is being guided by Hero Code. Okay, so I want you to understand that for us to design our slab, basically we are trying to, find out those moments that are generated in that slab and also provide the required reinforcement that will be able to overcome those moments, that are generated. Because as you know, design is basically to examine the reactions, the moments, that imposes stresses on our slab. Okay, we try to find out those forces. Then we now design reinforcement that will be able to overcome, to withstand and overcome those forces. Okay, those gravity forces on our structure. Okay, so now the slab in this context is usually made up of panels. Okay, so but let's just look at the procedure on how to design our ROC slab. Okay, so the first is you study the architectural floor building plan. Okay, the architectural building plan. All right, that is the first you're expected to do, because for you to start up your structural design, you must have received the architectural drawing from the architect. So basically the slab now is centered on your ground floor. Okay, because your ground floor is what will carry the slab. Okay, depending on the number of floors. So as the first floor slab is what you have to get from your ground floor. Okay, the ground floor orientation, the partitions is what determines the slab that will come on it. Okay, so if you're going for the second floor, you know that the first floor slab is what will come on the second floor slab is what will come on the first floor slab. So that is how the sequence is. Okay, so first and foremost, you receive the architectural drawing, you study the architectural drawing, and under architectural drawing, the basic thing you need to look out for, you have to look out for the dimensions. Okay, the dimensions. You look out for the dimensions. All right, you look out for the dimensions. You look out for the spans. Okay, you look out for the spans. All right, the spans, I mean the distance between one partition to the other. Basically, those areas you have your column points. So these flexural members are hinged, like the slab is hinged to the beam. All right, while the beam is hinged to the columns. So these partitions in that architectural floor plan, you have to determine the positions of these structural elements. So this trying to study the architectural drawing, you look at the dimensions, you look at the spans, and the span is basically the partitions, you know, within that building. All right. So once you have done that, the next you're going to do is what we refer to as paneling. Okay, referred to as paneling. Now, paneling now has to do with, you know, like I said, your slab is one unit, all right? But when you want to design, you need to split the slab into panels, smaller units, all right? So you have to design each of those units. Now, designing each of those units will enable you now provide reinforcement for each of those units. Then when you want to detail that slab, you have to now bring together all those sub-units, you know, into one. What I mean, bringing the individual reinforcement that is provided for each of those panels, you bring them together in one slab unit and detail appropriately. All right, so before you design, you have to segment, okay, you have to segment the slab into panels, right? For example, let's say we have, okay, you know, the slab now, you know, you have in a building, you have your sitting room, you have your main lounge, you have your porch, you have your dining area, you have your bedrooms, you have your kitchens, you have your lobby. All of these areas are what will form the panels. Okay, so forming the panels is based on your own discretion. All right, now understand that what we are doing now is just to understand the procedure on how to design our slab according to Hero Code. Now there are other procedures for the various structural elements, but we are based on our outline. Today's class is centered on that of the slab. So let's understand the procedure. So you first and foremost study the architectural floor building plan, which is the floor plan in this context. Look at the floor plan. Okay, the floor plan. Now under floor plan, look at the dimensions, you look at the span. Now you now panel. All right, so when you panel, the next you're going to do is to establish the boundary conditions. You establish the boundary conditions. Okay, now understand that each of these, for example, let's say we have something of this nature, okay, we have something of this nature. All right, now when this is a slab, for example, now you have to establish the boundary condition. Okay, and like we say paneling, we can say this is panel 1, this is panel 2, this is panel 3. All right, so that is the paneling I'm talking about. You have to show this is a panel 1, 2, 3. So you treat them in that sub-unit. All right, so at the end of the day, you're expected to design this panel, provide reinforcement for this panel, design panel 2, provide reinforcement for panel 2, design panel 3, provide reinforcement for panel 3. Then you now bring back the reinforcement back to it as one slab. So that is what the design is all about. So establish the boundary condition. Understand that this panel 1 is connected to panel 2 and panel 3. Then panel 2 is connected to panel 3 and is also connected to panel 1. So there is this boundary condition. Remember, the beams, the slabs are hinged to the beam. So in this context now, you have a beam here. Okay, you also have a beam here. Okay, you have a beam here. So what it simply means by boundary condition now, it means that there is a connection here. Okay, so at this point it is continuous. It is termed as continuous. So under here we have continuous. Okay, we have continuous edge. Okay, then we have discontinuous edge. Okay, we have discontinuous edge. All right, so Now, understand that at this point now, 2 and 3, they are continuous because they are connected to a beam, all right? While 1 is also connected to 2 and 3 at this point, all right? So if you look at 2 now, you see that 2 is connected at this edge, is continuous at this edge, continuous at this edge, but it is discontinuous at this edge as well as this edge. So there is a case, all right, that satisfy panel 2, all right, and that is, by the time we talk about moment coefficient table, that is where this will come to play. So as we progress, we'll also get to that, but I want you to understand this. So by the time we are talking about those moment coefficient table, okay, moment coefficient table, it will be easy for understanding. So panel 3 now is connected to panel 2 and panel 1. All right, there is a condition dissatisfied. Then 1 now is connected, is continuous at one edge, but discontinuous at 3 edge. Okay, it's discontinuous at 3 edge. So there is a case that dissatisfied. So the geometry of your building, by the time you segment it, you now discover their various cases based on their boundary condition. All right, so the next you're going to look out for is to understand the aspect ratio. Okay, you understand the aspect ratio. All right, so I think we are going to pause here for now, and we'll continue in our next class. Thank you very much and have a wonderful day. Bye.